So on 1st Jan 2015, Mrs. Y puts $200 into a bank account. So we could help ourselves by doing this 1st Jan, okay, $200 right into a bank account, and the first day of each subsequent month, that means 1st February, she puts another 200 into the bank account, right? The interest rate is 0.25% per month, so that on the last day of each month, the amount in the account and day is increased by 0.25%. Therefore, I think I should, because they say at the end of the month, so I should write like this. So by the time this amount, the amount first invested in put in the account 1 Jan, by the time it reaches end Jan, it should give you 1.00, because 1% is 1 here. 0.25% should be 1.0025. That's how we calculate the amount. So this is the amount at end Jan. Now at 1st Feb of subsequent months, it add another 200. So I'll have something like this: 1.0025 times 200 plus 200. Correct. And we can imagine that this thing will go on and on. So that on the last, okay, let UN be the amount in the account at the end of nth month. That means they want the end of nth month. This is the end of 1st month. Correct? This is the end of the 2nd month would be end of Feb would be this. 1.0025 would multiply to this thing, so I will get 1.0025 square times 200 plus another 1.0025 times 200. That is the end of the 2nd month. So they want to know, let UN be the amount in the account at the end of every month, where 1st month refers to January 2015. Okay, so show that the amount in the account at the end of February 2015 is 401.50. That means I want to show that this thing is equals to 401.50. So I will do a quick calculation on the calculator. Again, clear. 1.0025 square. Nope. Delete it. Go back. 1.0025 square times. Nope. Let's go. 200 plus 1.0025 times 200. That's why I key into the calculator and press enter. Indeed, I get 401.50. See the figure here, 401.50. So I go back and then prove that this thing is a amount in accounts at end Feb equals to this thing, 1.0025 square times 200 plus 1.0025 times 200 equals to $401.50. This confirms our understanding is correct. This question actually helped us to confirm that here we are correct, right? It's actually a question that helped us, right? So and then question part 2, show that UN equals to this. So U1 is this, U2 is this. So what is my UN? Simple. When U1, this is only one term. When U2, this is two terms. And how many terms are there when I go to UN? I expect that there are n terms. Okay, this series will look like this. When it comes to UN, the series will look like this: 1.0025n, because you see, second, this is 2. So when n, it is n, right? And the 200, then plus 1.0025 n minus 1 times 200, okay, then plus all the way to the first term, 1.0025 times 200. Okay, so this would be the un term. And what kind of series is this? Right, we could further factorize out this thing if we want to. Actually, there's no need, but let's try it. 1.0025 n minus 1 plus 1.0025. This is, so how many terms are there? There are n terms here. And what is the first term? The first term is this. And what is the common ratio? The common ratio is 1.0025. You see, 1.0025 multiplied by 1.0025 will give me 1.0025 square. So this is actually a geometric series, geometric progression with number of terms equals to n. Then what is the common ratio? Common ratio is equals to 1.0025. What is the first term? First term is 1.0025 as well. So to summarize this, we will use 200. Okay, 200 is not a part of the geometric progression. So the first, you use this formula for sum to n terms for geometric progression. The first term, 1.0025, correct? A, which is, okay, which is, I shall write it out for you. So this is A, 1 minus Rn, or 1 minus R. So R is my common ratio, right? N is my number of terms, happen to be n as well. So don't get confused. So A is the 1 so we have 1.0025 1 minus 1.0025 n, okay, and 1 minus 1.0025. Okay, so this thing I will put it inside. So I'll get 1.0025 1 minus 1.0025 n, okay, then 1 minus 1.0025. Okay, so the next step is to simplify to the simplify to the form that is given to us. How to simplify? We'll just take 1 minus 1.0025 is minus 0.0025. 200 divided by minus 0.0025. Let's see what's that. Times this. So I want to calculate this part, right? This part. Just 200 times 1.0025 divided by minus 0.0025. So 200 times 1.0025 divided by minus 0.0025. Okay, this is actually 1 minus 1.0025. So I get this. So I have enter minus 80200. So I go back. Minus 80200. Therefore, this part has reduced to minus 80200 and 1 minus 1.0025 n. Okay, the minus, if you just multiply inside, it will be 80200 1.0025 n minus 1. I switched this. Right, so that will be exactly the answer that is given to us. Now find the month and year on which Mrs. Y puts in her last monthly deposit of $200. Find the month and year on which Mrs. Y puts in her last monthly deposit of $200. What does it mean? Why would there be a month and year where they put in the last $200? Oh, okay, I missed out part of the question. There is the part that says that insert part of the question here. Mrs. Y decides to stop her monthly deposit of $200 once amount in account exceeds $20,000. So we must therefore be asking this: find the month and year on which Mrs. Y puts in her last monthly deposit of $200 is equivalent to us asking you when these amounts exceeds $20,000. So I will do this 80200 times 1.0025n minus 1 greater than $20,000, and then I will find the n. Then I will get the answer. So let's do this. So 1.0025 n is just greater than greater than 20,000 divided by positive number. When you divide, you don't have to change the inequality sign, because when you're dividing by a positive number, and then this 1 I will add to the others, minus 1 bring over, be at 1. So then the next thing is when I ln both sides, 1.0025, I ln to bring the n down, because ln 1.0025 n is just n ln 1.0025 n greater than ln. So when you ln both sides, because ln is a strictly increasing function, therefore when you ln both sides, you do not have to change the sign, and you can do that, right? So 20, so I just make it simple. So 200, because since the 0 cancel away, 200 over 802 plus 1 must be the entire thing, right? So then ln anything more than 1 is a positive number, right? When you ln anything more than 1 is a positive number, so I could just divide this over without changing the sign. But let's say if you divide something like that's ln like 0.5, then when ln 0.5 is a negative number, when you divide over the sign, the equality sign must change. So then we'll have ln 200 over 802 plus 1 divided by ln 1.0025, and then I'll get a single answer. So 200, 802, 1. 200, 802, 1. Okay, so I will just go back to the calculator. Just do ln 200 divided by 802 plus 1, and then I'll divide it by the whole thing by, okay, just in case, I would always like to play safe by including additional brackets, right? So then I can be sure that they do not ln the wrong stuff, right? So divided by ln 1 0.0025. Am I right? Let's check. 89.16. 89.17 in fact. So 89.17. That means n has to be greater than this value. That means my n is equals to 90. Alright, because n can only take integer numbers. If n is equals to 90, then what is the month and the year? So let's see this. What does our n stand for? Our n, U1 stand for n Jan, U2 stand for n February, correct? Therefore, U90 stands for what? Okay, maybe I will erase the no, I'll go to the next page. So what is what does N90 stand for? U90. So U1 is N Feb. N Jan. N Jan 2015. U2 N Feb 2015. Therefore, I jump to U12 must be N December 2015, correct? And that means U, a multiple of 12 that's closest to 90 is, what about U84? U12, 24, 36, 48, 60, right? 60, 72, 72, 84. Yeah, 84. So U84 is N December. What is the year? So every cycle of 12, so this is the 7 times 12. So 1 times 12 is 2015. 2 times 12 is 2016. So 7 times 12 is 1 minus 1, 0. So 201. So 7 minus 1, 6. 6 plus 2015, 2021. Am I correct? So let's test it with, let's say, what if it's 2? So 2 minus 1 plus 2015 will give you 2016. Correct. So 7 minus 1, 6 plus 2015 will give me 2021. Therefore, this one is correct. I've gotten the year right. Now I need to, this is 2021. Now U90 doesn't reach the next year, so this is 2021, U90. So U84 is, so U85 would be, so U85 would be beginning, would be the N Jan 2022. Correct. So if then 6 would be, so how many? 6 minus 1 plus 1 will be February. 90 minus 85, 5 plus Jan, 5 plus Jan would be June. And June 2022. Five minus, so U86 is N Feb. Yep. $86 is 6 minus 1 will be 2. Okay. 90 minus 5 5 plus 1 will be 6. So end June 2022. So let's double check whether it's correct. In June 2022. Just to be sure. Yep, so end June 2022. Since that means when Mrs. Y put in the deposit the last $200 in end June 2022, in beginning June 2022, so beginning June 2022, because at the beginning of every month he deposit $200. So at the beginning of June 2022, she deposit the last $200, and then by the end June 2022, the amount grow to more than $20,000. So she stopped depositing. Right. So she stopped depositing in the month June 2022. Okay. So now we go to part for how much compound interest will she earn at the end of the month, found in part 3. So compound interest. Okay, so the thing is, at the end of the month, so we find out what is U90. Alright, U90 is the end of that month. So we use the formula U90. U90 is the total amount at the end of that month, but we must minus away the amount that is deposited up to U90. So U1 you deposited $200, right? By the time U90 you deposited 90 times $200. Just 19 months had passed. Each month you deposit $200, so 90. This is the amount deposited. This is the total amount in the account by the end of the 19th month. So she earned at the end of the month found in part 3. So for this type where the thinking is very tricky. It's very tricky. You have to think slowly and make sure it's accurate. You need to double check your thinking. So U90 minus 90 times 200. Let's see. U90, I will just use this formula to calculate what is my U90, which is 80200 times 1.0025 to the power of 90 minus 1 minus 90 times 200. So for such questions, I will recommend you to leave till the last, because it requires a lot of careful thinking. So you leave it to the last. You don't spend too much time on such a question that you don't have time for other questions during a exam situation, right? So I will just key this into the calculator. So 80200 times 1.0025 to the power of 90 and minus 1. Okay, then this is the total amount. I will minus 90 times 200 and I get 2208.09. 2208.09. So equals to $2208.09 of compound interest I've earned on the account. Just make sure that I did not do the wrong calculation. The power of 90 minus 1 minus 90 times 200. Yes, that's correct. So I have solved this question. This is the part 4 answer. This is the part 3 answer is on the next page. Okay, and that's it.